So welcome to part 5 of this lesson. This is the final part where we will be answering this question using our CAS calculator. So it's going to be rather quick and it's going to be really important because you need to be comfortable with using your CAS. So we need to find the area bounded by this curve and the x-axis. So as we know, in order to answer these questions, we need to figure out which area is above and below the x-axis. So I'm going to have to sketch this. Now that's pretty good because it's factorized for me. So it's going to be very easy to find what my x-intercepts are going to be. They're going to be -1, they're going to be 3, and they're going to be -4. So I can come down here and say, well, that's going to be -4, that's going to be -1, and over here will be 3. I then am going to give this a sketch, knowing that this is positive, and this is positive. So if I was going to expand this, I would end up with a positive x cubed. So my graph is going to start by going up, then it will go down, then it'll go up. Now, that's an ugly, ugly graph, but it doesn't matter because I'm not being graded on my graph. I'm being graded on giving the proper answer. So having drawn that, I know that I'll be finding this area and I'll be finding this area. Now, by the wording of the question, which says find the area, I know what I'm after is the total area. I'm not after the signed area. I'm after the total area. To find the total area, what am I going to do? Well, I'm going to take the definite integral between -1 and 4, -1 and -4. And instead of writing this whole thing here, let me just go y is equal to f of x. And now I can just chuck in f of x here because I'm going to end up putting this into my calculator anyway, so I don't want to waste our time by writing things out. And now I've got this area right here. So this one right here, this is positive because it's above the x-axis. But this one right here, because it's below the x-axis, is going to be negative. If I want to figure out what the total area is, I'm going to have to chuck a negative out the front. So that negative and negative becomes a positive, and I'll find what the entire area is. So this is going to be 3, -1 of f of x, d of x. Perfect. Having done that now and done everything I needed to, I will now jump over and start using my CAS. So having done that, I'm now going to use my CAS. Now, what should we do first? The first thing that I would do is, and I think you should do this as well, you're going to want to define what our function is. So define f of x as being x plus 1, x minus 3, and x plus 4. Having done that, we've got that. Now, we've been able to graph this really easily because it was already factorized for us. So we did the graphing ourselves, but let's imagine you're in a situation where you haven't been giving something that's factorized. You would have to go through a long process of like polynomial log division and factor theorem to get it in the factorized form. And that would be a real waste of time if you had your CAS. So let's just imagine that we were given a really disgusting cubic. What you should do is you should graph it with your CAS. So let's just do that for a moment. So we've been given a nice one. So let's just look at it. There it is right there. So we can clearly see, what it is. And we know what these points are because it is factorized. But imagine if we didn't. You should use your CAS to do this step. You should use your CAS to figure out what's above and what's below. You'll have to find your x-intercepts. There's a few ways to find the x-intercepts. You can go menu, you can go analyze graph, and you can go 0, and then you can start doing things like this to find what they are. I find that quite long and cumbersome. There is this little hack that you can use, and that is, let's hit tab, and let's put in y equals 0. So that's literally your x-axis. Then you can go menu, you can go geometry, you can go points and lines, and you can go intersection and points. And then you click on the two things you want to find the intersections of, and just like that, you find the points right there. So there's a little hack there using that. So feel free to use that if you ever need to find the x-intercepts. The other way you could find the x-intercepts would be here in this page right here. What you could do is you could just go solve for the function is equal to x for the is equal to 0 for the x values, and just like that, you find the x-intercepts. There are other ways to go about it, but those are just two ways. The moral of the story is, if you weren't given a nice factorized form graph, you wouldn't waste your time trying to do it by hand, graphing it. Just use your CAS if you have that option. All right, so having now done that, let's actually get to the meat of this topic, or this video, and that is putting in this. It isn't tricky. All you're going to do is go menu, you're going to go calculus, you're going to go integrals, and then you're going to chuck in -4, you're going to chuck in -1, and because I've already defined what f of x is, I'm just going to chuck that in there, minus, and then what I'm going to do, oops, don't hit space, hit the arrow key, minus, and then you're just going to do it again. Menu, calculus, integral. And this time it's from -1. This is f of x. And this is 3, because 3 to -1, good. And then this is d of x. Having done that, you hit enter, and there's your answer. As you can see, it is a disgusting answer, and that's why I did it on the CAS. If you wanted to find the signed area, what you would do is you'd go menu, you'd go calculus, you'd go integral, and you're just going to go from -4 to 3. So -4, that's not a 4, -4, f of x to 3, d of x, -343 over 12. And if we come and look at our graph for a moment, that's telling us that we're ending up with more negative. So if we would just zoom out for a moment, whoops, I need to get rid of that. Zoom out. Yes, as you can clearly see, I have more area underneath the x-axis than I do above. So it makes sense that my signed area would be negative. So now if we come back here for a moment, and let's just zoom out here and let's put in what we have found. We have found, where's my pen? We have found that this right here would be 937 over 12. And if we wanted to find our signed area, what it's going to end up being is just the definite integral from -4 to 3, -4, of f of x, d of x, that would be equal to -343 over 12. And just like that, we have finished this lesson. I think that's everything I wanted to tell you. Hopefully you feel comfortable using your CAS. Hopefully you know the difference between signed and total areas. And yeah, that is it. It's been a rather long topic, but hopefully all of it made sense. Let's just look over everything we've done. So much work. All right, I will see you in the next lesson.